Welcome to the cyclic redundancy check of the HT8 MCU basic tutorial. This course will take you to understand the cyclic redundancy check of the HT8 MCU from the following four aspects, which are CRC Introduction, CRC Checksum Calculation, Register Introduction, and Application Examples. CRC Introduction. What is in CRC? The cyclic redundancy check, known as CRC, is a technique used to detect and verify whether errors occur in data transmission or storage. The transmitter calculates the CRC checksum based on the sent data and the generating polynomial, attaches the CRC checksum to the end of the data, and sends them together. The receiver calculates the CRC checksum based on the received data and the generating polynomial, and then compares it with the transmitter CRC checksum. If they are the same, this indicates that the data is correct. The CRC check is often used in communications such as USB and CAN bus, which is one of the important means to ensure the reliability of data communication. It should be noted that the CRC is mainly used to check for errors and not to correct them. CRC Checksum Calculation. Next, let's take a look at how to calculate the CRC checksum. The first step is to determine the generating polynomial and the corresponding binary code. First, set the generating polynomial and expand it. Then, according to each coefficient, the corresponding binary sequence is 1101, and the highest power is 3. The second step is to shift the data to the left and add zeros to the lower bits. First, set the information code to 101001. Then the pre-processed data is 101001 followed by 3 zeros. The highest power of the generating polynomial is determined by the number of zeros added to the lower bits. The third step is to execute modulo 2 division and find the remainder. First of all, we need to understand the exclusive OR operation, which outputs 0 only when both inputs are the same and outputs 1 only when both inputs differ. For the shifted data, the generating polynomial is used for modulo 2 division, and the CRC checksum is obtained as 001. Next, let's take a look at the considerations. When the CRC checksum is calculated by hardware, various MCUs support different generating polynomials. For more details, refer to the datasheet. When the CRC checksum is calculated by software, the generating polynomial can be selected according to the requirements. However, in the case of the same parameters, it takes longer than hardware. Taking the HT66F2362 as an example, the integrated hardware CRC only supports the 16-bit CRC calculation results using the CCITT CRC16 and CRC16 generating polynomials. The time required to calculate the CRC checksum is as follows. For more details, refer to the application note HT66F23 series CRC application guidelines in the Holtec official website. Register Introduction. Take the HT66F2362 as an example. Let's first get to know the related registers. The CRCIN register is used to input new data. The CRCCR register is used to select which CRC generating polynomial. The CRCDL register is used to store the CRC checksum low byte data, and the CRCDH register is used to store the CRC checksum high byte data. Application examples. Take the HT66F2362 as an example and calculate the CRC checksum using hardware. We set to send 4 bytes of data and 2 bytes of CRC checksum. The first step is to clear the checksum register. The second step is to select the generating polynomial. The third step is to write the data into the CRCIN register sequentially. Then obtain the result. Finally, send the data and the CRC checksum. Let's take a look at how the receiver compares the CRC checksum. First, receive the data in CRC checksum. Then, calculate the CRC checksum based on the received data and the generating polynomial. Finally, compare the checksum calculated by the receiver with that of the transmitter, and write the code according to user's requirements. Course summary. In this course, we have learned about what a CRC is, CRC Checksum Calculation, and related registers. Through the study of this course, you will have a certain understanding of the CRC. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.